Welcome to linear integrated circuits videos. So in this video we shall see 555Timer and its applications. So this is in this video we'll be discussing only the basics of it. So in this video we are looking at the 555Timer construction and one of the application, that is that is Monostable Multivibrator. Now let us first have a look at what is a 555Timer. So 555Timer is a linear integrated circuit. It is used to generate signals of desired duration and frequency. So you can design it for any particular duration, on and off time, and whatever frequency you want to generate, you can generate. The output levels may change conditionally or unconditionally after the predefined time. Meaning the output voltage, whether it is 0 volt or VCC, will be changed conditionally with respect to a particular condition, or it can be keep on changing unconditionally after a predefined time. So these are the type of output signals you can able to get from a 555Timer. Now there are some prerequisites before we start understanding what is a 555Timer and what are its applications. One of the very important prerequisite is a potential divider. So let us consider three resistors of same value. Here we have just considered R1, R1, R1. There are three resistors are connected from VCC to ground. We are trying to see two nodal voltages. One is VTL, other is VTH. So from this we can clearly understand that VTH stands for the upper higher threshold voltage. V is the voltage, TH stands for the threshold, so it is H, it is we simply call it as higher threshold voltage. So from this circuit diagram, since the values of the resistors are same, the voltage at VTH node happens to be 2/3 of VCC. So similarly, the voltage at this particular node, which is named as VTL, that is lower threshold voltage, happens to be 1/3 of VCC. So with this prerequisite, so we can able to certainly understand the working of the 555Timer. So we're going to have three resistors of same value connected between the VCC and the ground. The voltage at one of the nodal point, which is VTL, is 1/3 of VCC. At VTH it is the 2/3 of VCC. So we are calling it as VTH because it is the higher threshold. This is a lower threshold voltage. So another prerequisite is the op-amp as a comparator. So as you can see here, we are having a comparator with plus VCC and VEE connected as the power supplies, and this is V minus. We call it as the voltage at the inverting terminal and voltage at the non-inverting terminal. So we know that the output voltage is the open loop gain times the differential voltage, that is A0 into V plus minus of V minus, the difference multiplied by the differential gain. Now when the condition is when V minus is greater than V plus, that is voltage at the inverting terminal is greater than the voltage at the non-inverting terminal, the output voltage is at minus V sat. Because we are not having any feedback here, the output voltage ends at a negative saturation because voltage at the inverting terminal is more than the voltage at the non-inverting terminal. It is the vice versa. When the voltage at the non-inverting terminal is more than the inverting terminal, the output voltage is plus V sat. So with this basic, we shall also see what is another prerequisite for understanding the 555Timer. So this is a RS flip-flop, stands for reset and set flip-flop. So there's a truth table given also. Suppose if the input R and S are 0, 0. So here I'm talking about the logic levels. So instead of 0, 0, the exact voltage will be 0 volt and 0 volt. In such case, the output voltage will not have any change. So Q and Q bars will be complement to each other. If it was if Q was 0, it continues to be 0. If Q is 1, it continues to be 1. If it is R is 1 and S is 0, that is R is VCC and this is 0, so we're going to have a reset operation. So reset will make a Q bar as 1. So this is making set 1 and reset 0. So here it is, you're actually setting the output voltage. If it is 1 1, it is an auto load condition. Now you can see this is the exact circuit diagram what we are seeing for a 555 timer. So this has got 3 resistors connected from VCS to ground, and there are 2 comparators, comparator 1, comparator 2, and you can see one of the terminal is connected to VTH, which is inverting terminal. Here VTL is non-inverting terminal. The outputs are connected to uh, reset and set of the flip-flop, and output Q is the final output, and Q bar is connected to the transistor to turn on and turn off. We have a few terminals like threshold voltage, trigger voltage, and discharge. So these are the terminals corresponding to 555 timer IC. And one thing to note here is that the comparator 1 and 2 will give you plus Vsat as plus VCC and minus Vsat as 0 volt. Here we will not be using any negative voltage, so minus Vsat is actually 0 volts. And you can integrate all the prerequisites and try to find out, okay, how does this works. Suppose if the V threshold voltage is if you just have a look at this, if V threshold is greater than VTH, so as you can see here, if the threshold voltage is greater than this voltage, so V plus is greater than V minus, so I'll end up with a this is equal to, the comparator output will be equal to high. So if this is high, you're making R is equal to 1. So when R is 1, you are forced to reset the output. So that's why the output is becoming 0. So when threshold voltage is greater than VTH, the output voltage of the entire timer output is 0 volt. Similarly, if the trigger voltage, V trigger, if it is less than VTL, so as you can see here, since VTL is connected to the non-inverting terminal, the trigger is connected to the inverting terminal. Suppose if the trigger voltage is less than the VTL, so this takes upper end over this, so output voltage will be now here this will be more compared to this. So when VTL is more than, now we are looking at the trigger voltage less than VTL. So when the trigger voltage is less than VTL, so this V plus is more than V minus. When V plus is more than V minus, this comparator output voltage becomes 1. So when set becomes 1, the output this Q will become 1. So when Q becomes 1, the entire output of your 555 timer becomes high. Meaning when trigger voltage is less than VTL, VTL is more than trigger, so this comparator 2 output is high, which is the set output, the set input for this flip-flop. When set is 1, we know that from the previous truth table, when set is 1, when reset is 0, we're going to end up with the output Q as 1. So since Q is the actual output, we're going to get the output as VCC. Now let us have a look at, okay, what is this multi-vibrator is. So multi-vibrator will have 2 states. So one is low, other is high state. So low state corresponds to 0 volt and high state is plus VCC. So what is this monostable multivibrator? So definition of monostable multivibrator is, as the name itself indicates, it has got only one stable state and other state is quasi-stable state, we call it as. Quasi means the temporary state. So one state is stable, the other state is it goes to other state from a stable state, but when it goes to other state, it will not be stable there for a longer time, so it will come back to that stable state after some time. So it is temporarily going to that state. Now 555 timer has got stable state as 0 volt and quasi stable state as plus VCC. So this is what is in a 555 timer monostable multivibrator. The stable state is 0, quasi stable state is VCC. So mono short, how it actually works, the output will remain in the stable state of 0 volt unless the circuit is triggered to go to quasi stable state. If you're not invoking the mono short to go to a trigger, if you're not giving a trigger signal, output remains to be there in a stable state unless a trigger is given. If you give the trigger, it goes to quasi stable state, stays there for some time, and it comes back to the stable state. Now as you can see here, the output will be in quasi stable state of VCC for a predefined time and goes back to the stable state of 0. Now when you give a trigger signal, it goes to quasi stable state, stays there for a predefined time, and then again goes back to 0. So whenever it is going back to 0, we must ensure that there is no more trigger signal available. So that's what it is. If the trigger is disabled, so once it goes to quasi stable state, it will come back to stable state after a predefined time. So in order to go to quasi stable state, you have to give a trigger. Once the trigger is given, it is there in the quasi stable state for a predefined time, and it will come back to stable state of 0 volt. When it is coming back to 0 volt, make sure that there is no more trigger. What is this trigger signal? So trigger signal is a voltage for this especially 555 timer mono short. Signal with voltage less than 1/3 of VCC is the valid trigger signal. So signal with voltage less than 1/3 VCC will push the mono short to quasi stable state. So this is a trigger signal whose amplitude is less than 1/3 VCC will going to make the mono short to go to quasi stable state from a stable state. Now you can see the complete circuit diagram. So the one which is there in the blue is the 555 timer, and this is that external components required to realize that mono short, and you can see the waveforms. So as the name itself indicates that, okay, this was the trigger pin. Here you are actually giving a trigger signal. So this is high going low and then again going high, and this is the voltage at the capacitor. This is a resistor which is used to charge this capacitor to VCC, and you can see the waveform. So this is a trigger signal which is VCC. So now when VCC goes below VTL, this is a trigger signal. Whenever the trigger signal is VCC, it is not a valid trigger, so the output remains there in the stable state. You can see the output is 0. The capacitor voltage is also 0. Once the trigger signal goes below VTL, that is 1/3 of VCC, I can see now the output has gone to quasi stable state. It remains there in the quasi stable state for a predefined time. So that predefined time is T. So this T is decided by this R and C value. So it is given by that T up to which the output remains there in the quasi stable state is RC into ln of 3, which happens to be 1.1 into R into C. So after this time T has elapsed, the output again goes to stable state. I can see whenever it is going to stable state, so I have ensured that there is no more trigger signal, valid trigger signal, that is the trigger signal has gone above 1/3 VCC. So this is the trigger signal where it is less than 1/3 VCC. So during this time the output is made to go to quasi stable state. It remains then the quasi stable state for a predefined time of 1.1 into C into R, and then it comes down and it is now staying in the stable state. Unless you give one more trigger signal, it remains to be there in the stable state. Now let us see how does this actually works. Now we'll just see in first stage. So it's in stable state. So we shall assume that the capacitor voltage is 0. So when this is plus VCC, that is trigger voltage plus VC. So this red line indicates, so we are trying to see the operation of this mono short during this region of the uh, voltages. So the trigger voltage is plus VCC, as you can see here. So this voltage is 0. So let us try to see what is the comparator voltages. Now here it is 0 volt, 0 volt. So why it is 0? Please have a look at this. So the comparator 1 V plus is this, that is capacitor voltage 0. Here it is 2/3 of VCC. Here it is 0, here it is 2/3. So V minus is more than V plus. So that's why it is at minus V sat. So minus V sat, in this case it is 0 volt. Coming to this, so here VTL is at 1/3 of VCC, whereas this is at VCC. So again now this is less compared to V plus is less than V minus. The output is again V minus is now greater than V plus. So when V minus is greater than V plus, we know that output is 0. So if it is 0, 0, let us see in the next video what happens.